Okay, so I think we can start now. So, hello everyone to the first assignment class. So, we will quickly go through the assignment 1 of your course Introduction to Classical Mechanics, that is page 28. Okay, now uh, can any one of you uh, say that whether my screen is visible or not? Okay, fine, thank you. Okay, now let's start with the questions. So I don't have the questions in my screen, but I think you have gone through the questions. So the first question was about the degrees of freedom. So how many degrees of freedom does a particle have moving on a sinusoidal curve? Now you know what is the degrees of freedom. Degrees of freedom is actually the number of parameters, the minimum number of parameters using which we can define a position of a particle. Now for a sinusoidal curve, this is y, this is x, and this is the sinusoidal curve. Don't pay attention to my drawing, just to give you the idea I have done that. So let's say y is equals to a sine x. Now you can see this is a 2D plot, but here the y is related to x. So for every x there is a y we can calculate from this function. So y is dependent on x. That's why the degrees of freedom here is only this x parameter. So although it is a 2D plot, but the degrees of freedom is 1, that is x, not the y, as there is a relation between y and x. Now similarly, the second question was the degrees of freedom of a particle moving in a sphere or something in the surface of the sphere. Now you know this is the sphere. Now for a sphere we need r, theta and phi coordinate, right? So three coordinates we need to define a sphere. But as the particle is moving at the surface of the sphere, that means the distance from the center is always fixed, as it cannot enter into the surface. That's why the r, whatever the value is, that r is constant. But theta and phi, these two are variables on the surface of the sphere. So the degrees of freedom for a sphere is actually 2. Degrees of freedom for a particle moving on the surface of a sphere is actually 2, that is theta and phi. These two can vary, but the value of r, that is fixed for the surface. So it is degrees of freedom 2. Okay. Now coming to the, so meanwhile if you have any question you can ask, no problem. Now the third question was, what is the we need to calculate the normal of a given surface. Now I will do some mathematics here. So suppose this is the surface and this is a point A. Suppose the coordinate of A is xyz. I am taking the Cartesian coordinate, and the equation of the surface, this surface, is, let's say, phi xyz is equals to 0. Like in your question it is given that the equation of the surface is x plus 2y plus 3z is equals to 0. Okay. Now it is same, it is the phi xyz. Okay. Now suppose the r is the position vector of A, which we can write as xi plus yj plus zk. General coordinate is 3, but the degrees of freedom is 2. There was a question from Rakibul. So this r is the position vector of A. So if we take the differentiation, it will be dxi plus dyj plus dzk. This is the dr. Now this, take this phi and differentiate it. D phi equals to 0. So this d phi can be written as del phi del x dx plus del phi del y dy plus del phi del z dz is equals to 0. Now this expression can be written in this form: del phi del x I plus del phi del y j cap plus del phi del z k cap dot product with dx I plus dy j plus dz k, that is equals to 0. Now this is very obvious, it is grad of phi and it is dr. This dr is same with this dr. Now as dr was the position of this particular point A, so dr lies on the plane of the phi plane. So if grad phi is grad phi dot dr equals to 0, then that means grad phi is always perpendicular to dr. It is a property of the cos product. There will be cos theta, and theta is 9. If theta is 90, then this whole thing is 0. So grad phi is perpendicular to dr. Similarly, grad phi is perpendicular to that phi surface. So the main point to do is that if any phi is given to you and you have to calculate the normal, then grad phi is actually the normal to that phi surface. So our phi was given as x plus 2y plus 3z, x plus 2y plus 3z, sorry 3z. Now the normal would be grad phi, that is del del x plus del x I cap del del y j cap del del z k cap and x plus 2y plus 3z. So the result will be del x is 1 I cap 2 j cap plus 3 k cap. So this is the normal vector of this particular of that particular surface phi. Now if you want to calculate the unit normal, then you have to divide this by the magnitude of this particular vector, nothing more. So the main point, always remember that grad phi is always perpendicular to the surface phi. Whenever phi is given, you can you just calculate the grad phi, that will be the normal or parallel to the normal of the surface. Okay. Now coming to the next question, that was about the Kronecker delta function. So I hope you all know what is the Kronecker delta function. So delta ij is the Kronecker delta function. It is 1 if I equals to j and 0 if I not equals to j. This is the definition of the Kronecker delta function. Now we have to calculate, according to the question, the value of delta kk. And you know that according to the Einstein convention, if any of the index repeated, that means there is a sum over that particular index. So delta kk actually means delta kk summation over k from I 1 to infinity or whatever the range of the k. So for us it will be, our range is k is only from 0 to from 1 to 3. So it will be delta 1 1, delta 2 2 and delta 3 3, and you know that the value of delta 1 1 equals to delta 2 2 equals to delta 3 3 1. So that is, your answer is 3. Okay. So it is a very simple one. Now and yes, now the second thing, it was the second ai delta ij bj. Okay, just a second. Yes, now what is this? This is actually the same thing. Here I is repeated and j is repeated, that means there is a sum over I and j, and also only those delta function exist for which the I is equals to j. This delta function will exist, all the other delta function will be 0. That's why we can write it as ai delta ii bi, I equals to j. That means ai bi, because delta ii is equals to 1. So it is the answer of ai delta ij bij. So actually it can be written in a different way also. So ai bi means, according to the Einstein summation, a1 b1 plus a2 b2 plus a3 b3. Whenever you get the repeated index, treat is like ai bi and summation over I. This is the same thing. Now it can also be written as this way. Sorry, a1i, a2j, a3k with the dot product dot b1i, b2j, b3k. So you can see, if you do this dot product, you will get this result. So this ai bi can also be written as a dot product between two vector a dot b. Okay, so finally what ai delta ij bj can be written as ai bi as well as a dot product between two vector a dot b. So it is the definition of dot product between two vector a and b actually. Okay, now coming to the third one, sixth one, it is also application of delta function. So we need to calculate delta jk, delta jk. Okay, now it is also a very simple one. Delta jk means the those delta function will exist only which have the same index, that is j is equals to k. If j is equals to k, only those values will exist. So actually it is delta jj, and you know, if I write it in an open form, it will be delta 1 1. So all these delta values individually have all these delta function individually have value of 1, that means 1 plus 1 plus 1, that is 3. These are so simple things. Okay, now the next one. Yeah, it is okay. Now another application is a product between the Levi-Civita symbol I j k and delta jk. Okay, now as let us define the Levi-Civita symbol. So Levi-Civita symbol is can have value 1, minus 1 and 0, and for which case it will be 1. So write the 1 2 3 in the cyclic form. So when the index ijk will be in cyclic, that means 1 2 3 or 2 3 1 or 3 1 2 combination, for these combinations the value will be plus 1, and for the clockwise direction, that is this direction, say 3 2 1 2 1 3 or 1 3 2, for this just a second, yeah, for this it will be minus 1, and for all other cases the Levi-Civita value of the Levi-Civita symbol will be 0. I mean, if I equals to j, or if I equals to k, or j equals to k, if any of the two symbols are same, then the value of the Levi-Civita symbol will be 0. Now coming to that ijk delta jk, so you can see this delta jk, this is non-negative only when j is equals to k, right? Now if there is a problem with j equals to k, if j equals to k, then here two index will be same, I j j, suppose delta jj. So if j equals to k, then the first thing, the Levi-Civita symbol will be 0, and if j not equals to k, then the delta function is equals to 0. So whatever the combination is, the value of this particular product will always be 0, because either delta function will be 0 or the Levi-Civita function will be Levi-Civita will be 0. So this is the thing. I am asking you that whether can you tell me I have done the Levi-Civita symbol correct or not. I mean, I have done it ages ago and I have forgotten. So for 1 2 3 it is plus 1, right? Any of you can tell? Okay, okay, I was just confusing. Okay, so for any combination of jk, this particular product will be 0, j equals to k or j not equals to k. Okay, now yeah, the next one I will do at last. Now let us go to the differentiation of generalized coordinate. So the question was delta qi qj delta qk. So for this is the general differentiation type thing. Just take out the q, sorry, yeah. Degrees of freedom can be less than the generalized coordinate if there is some relation between them. Like for the first case, it was a 2D plot and the generalized coordinate is y and x, but there is a definite relation between y and x. So if you give me x, I can say you what the actually the y is. So the degrees of freedom is 1 here. Yes. Yes. No, degree. Suppose there is no relation between y and x, and the particle is somewhere in the surface. Then we need to define what the y is and what the x is separately, right? Yes. So that is the thing. That is the minimum number of parameters which you need to define a system, that is degrees of freedom, not the generalized coordinate. Yes, generalized coordinate too, right? But degrees of freedom is 1 because q1 is related to q2. There is a constant between them. Because if you give me x by this expression, I can tell what the y is, because your y is dependent on x, it is not independent. Like in the second case also, the generalized coordinates are 3, r, theta and phi, but your r is constant every time because it is on the surface. So the variable is only theta and phi, and the degrees of freedom is 2 for that case. Oh. Yeah. Now coming to the differentiation, so we can take the qi out, and del qj by del qk plus qj del qi del qk. Now this is actually this is 1 when j is equals to k, and this is 0 if j is not equals to k. So it can be written as delta function, delta jk and qj delta ik. So it is the result of this particular differentiation. Okay. So always remember that del qi by del qj is equals to delta ij. Yeah. Now the last question was the same, but they have given the same coordinate in the bracket. So same, in the same way, del qi del qk plus again qi del qi del qk. So 2 qi del q, so del qi del qk we will write it as qik. Now it is only non-zero if I is equals to k. So if we put I is equals to k, then we get 2qi or whatever 2qk as the answer. So this is the answer of this particular differentiation. Now coming to the question, another question number 8. That was yes, yes, yes. Okay, so it is. It, yeah, both are correct. So I don't. Yeah, and otherwise it will be 0. Only non-zero if I equals to k. So I think you. I think any of the options should be correct. I mean, and you must be awarded the marks for any of the choices. Okay, now coming. Now we have to calculate this thing, epsilon ijk, epsilon imn. Okay. So before doing this, I will do this one, epsilon ijk, epsilon lmn, where every index are same. Here you can see this I is same with the first index are same for the both Levi-Civita symbol. Now this can be written as this way, and I for the first row write delta I, second row delta j, and last delta k. Then write this lmn accordingly, lmn, lmn, lmn. So this is the way of expressing this particular thing. Now we will write the same thing with same index, I mean same first index, delta I. Okay, now imn, 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 imn. J K N. Now let us write it, I mean let me in a determinant form. So delta II, delta Jm, delta Kn minus delta Jn, delta Km minus delta Im. So this will be delta Ji, delta Kn minus delta Jn, delta K. Please tell me if I am wrong. Okay, delta Ji, delta Km minus delta Jm, delta K. Ijk, imn. I think it is right. Okay, now for the first multiplication, this with this, so you can see delta, there is a delta II, so repeated index means there is a sum over the I. So delta II, summation of delta II will give you 3, as I shown you earlier. So it will be 3 delta Jm, delta Kn minus 3 delta Jn, delta Km, right? These two are done. Now the second one, so delta Im and delta Ji. So you can see there is a repeated index I here, and it will be contracted, so that will be delta Jm, delta Kn minus plus. Similarly here this I will be contracted, so I think you know this thing. So delta Ki, delta Im is actually delta Km. If you write it separately, I mean by 1 2 index, k equals to 1, I equals to 1, you will find this. So it is called the contraction. The repeated index, it will be contracted, and the non-repetitive index will come in the final expression. So that I have done same thing. So this I will be contracted with this I, and it will be delta Km, delta Km, and delta Jn as it is. And the last thing here, I is repeated, so delta Jn and delta Km minus here this I is repeated, so delta Jm delta Kn. Okay, now you can see this is 3 delta Jm delta Kn, here 1 delta Jm delta Kn, and here 1 delta Jm delta Kn. So from 3 2 are subtracted, so only delta 1 delta Jm delta Kn is here, and similarly here 3 delta Jn delta Km, here 1 plus delta Jn delta Km, and here 1 plus delta Jn delta Km. So it will be delta Jn delta Km, right? So it will be the answer of epsilon I j k epsilon I m n. So this is the important, I mean, expression, you must remember that. So the method to remember is delta I j k delta I m n is equals to, first write this j with this m, I mean both the second index of Levi-Civita symbol Jm, then the third index of Levi-Civita symbol Kn, minus just the cross project, I mean not project, the cross thing, with j this n and with k this m. So that is delta Jn delta Km, right? So this is the important thing you must remember this, because you will uh, get this type of expression in your vector calculations, so it is a very important thing to remember. So this was the first assignment for the first lecture, and if you have any question you can ask me. Any other question not related to the assignment is also fine, I will try to give answer. Yes. How many degrees of freedom for a particle? Okay, so if it is a 3D problem, then the degrees of freedom is 3 I think, because gravitational field will not constant and will not give any relation between the coordinate systems, right? But if actually the thing is, the number of constant is the main thing. So if you have x y z coordinates, say 3 for a 3D problem, and you have a relation like x square plus y square plus z square equals to 1, suppose, okay, then although it is a 3D problem, but if you have the value of x and y, suppose this is 2, this is 3, then due to this relation you automatically know the value of z, right? You don't need the data for z if you have the x and y. So although it is a 3D problem, but the degrees of freedom will be 2 only, because this x and y. Similarly, if you have the value of y and z, then you don't need the value of x, because it can be calculated from this constant. So 3 coordinate and 1 constant, I mean equation, 1 number of constant, that for that the number of degrees of freedom will be 3 minus 1 equals to 2. Now here if you have another equation, x plus y plus z equals to 2, suppose, so you have this 3D problem and these 2 equations, right? Then only one of the x y z is sufficient for you, you can calculate the other 2 from these 2 equations. So for that case your degrees of freedom will be 1. So this is the case actually. Yes. Okay. Okay. Okay, so I have not gone through that video lecture yet. Can you tell me in which lecture it is? It 1 or 2? Okay. Okay, then I will go through the lecture, and it is a very specified question, and I will give you the answer next day. Okay, and I wrote your name, Ipsita Sinha, right? Okay, I will tell you, because it is not a general problem. I need to go through that what sir have done actually. Yeah. Yes. Yes. Mm, because how we cannot tell, because the gravity is acting at minus z direction, that doesn't give any constant to your equation. For this, the particle can be anywhere in this particular system, right? So you don't have any I mean any equation to tell what is the particular position of that particle if you don't have the x y z coordinate. So like suppose the earth, here also if you take a Cartesian coordinates, the gravity is acting downwards to the minus z direction, but we need three different coordinates x y and z to define a particular system. So that is the same thing. I cannot understand why there is confusion. Yes. uh, mgz cyclic coordinate, yes. Yes, x and y are not there. Yeah, it is an interesting thing. So okay. Okay, so okay, I will also check this, because currently it is not a good thing if I tell now. Maybe I may be wrong. Yeah. Yeah, yeah, sure, sure, sure. You should share all these thoughts. I will try to answer. Thank you. Yeah. Yes. So two particles mean you have to define two particles separately, x1, y1, z1 for a particular thing, and for the second the x2, y2, z2. And if there is no relation between that two particles, the degrees of freedom will be 6 for that whole system, not a single particle. So for this case, it is a two body system. Okay, then I think we can end today, and we will meet next week. And if you have any question, you can send me to this email address also. Yes. uh, Okay, so I think there is a book by Spigel, right? So that book is good for practice. I mean, for there are many problems in that book, so I find that book quite good. And to read, there is Goldstein always, and also there is a book from an Indian author, that is, I think, D.P. Rai Chaudhuri. That book is also good, but Goldstein is beyond anything. Yeah, for that you can check that D.P. Rai Chaudhuri or Chakwale Puranik. Those are the Chakwal Puranik. I don't know the exact name, so maybe the name is not right, but this is the author, two author. Yeah. Okay. Yeah, thank you. So we can end today and we will meet next week. Bye.